Welcome to Multiplanetary INnovation Enterprise, otherwise known as MINE. I am Jacob Unser, the Enterprise Manager, and I am accompanied by my peers to talk about three of our projects: Diver, Trencher, and Lunabotics. Our enterprise seeks to design, test, and implement robotic technologies that are capable of performing vital tasks in extreme environments. These environments currently include flooded subterranean caverns on Earth and the harsh lunar landscape, with opportunities for expanding in the future. As an enterprise, we are made up of over 80 students of various majors and interests that are spread across our three main projects.
Hello, I am Kenneth Valley. I am a member of the Implementation and Documentation Subteam within Diver. Diver stands for Deep Investigation Vehicle for Energy Resources. This project focuses on making an ROV to explore and map flooded mines, specifically exploring Quincy Mine. We aim to collect data for those interested in the possible implementation of renewable energy sources, specifically geothermal or hydroelectric power within Quincy Mine or other similar mines. Data collection involves mapping the environment with LiDAR to build a model to evaluate the structural integrity of the mine, as well as take readings on the makeup of the water. Our project had several phases. Phase 0 involved developing an initial design for the ROV capable of operating in pool and tank depth, as well as take basic readings of the water it is in. This phase of the project allowed us to test many of the general movement capabilities of the ROV. Phase 1 is the primary focus of the project. We are working on improving the ROV to autonomously operate up to depths of 400 meters and be capable of gathering additional data from its environment. The end goal of this phase is to do a shallow water test in the Quincy Mine. Phase 2 will be the final phase. This entails full mapping of the 2,000 meter depth of Quincy Mine. There have been many interesting challenges dealing with issues like water pressure and the confined environment of a mine. We are excited to continue work on this unique project.
Hello, my name is Andrew Westfall, and I'm a member of the Lunar Trencher testing team. The MINE Lunar Trencher project is designing, building, and testing a bucket ladder excavator in simulated lunar conditions. This excavator is a one-of-a-kind system, being the only bucket ladder to be tested in vacuum. Our project goal is to characterize the wear on our system's various components while excavating simulated lunar regolith both in atmosphere and in the dusty thermal vacuum chamber here on campus. The purpose of this research is to give quantitative measurements of wear on the system and compare how these measurements change when the system is in atmosphere versus vacuum. Key metrics tracked for our project include overall mass excavation rate, per bucket depth of cut, surface roughness measurements, mass deltas, and power consumption over time. These factors can tell us about our system performance and provide a basis for future testing of bucket ladder technology, and our data will be used to publish a journal article with a yet-to-be-selected aerospace publication. Throughout the academic year, our team has updated components and subsystems for efficient operation, as well as designed, manufactured, and integrated new components. We are also beginning the design process for lengthening our excavator to attach it to the Planetary Surface Technology Development Lab's Hoplite Field rover. Attachment to a mobile platform will allow us to further evaluate the performance of our system. NASA Glenn Research Center in Cleveland, Ohio has also sent us one of their bucket ladder excavation systems called Moonraker to compare both systems' design and performance.
Hello, my name is Zachary Gillish, one of the team members on the excavation sub-team on the Lunabotics project. Lunabotics is an annual competition hosted by NASA. Collegiate teams are challenged to design, build, and test a rover which operates in a simulated lunar environment. This year, the competition tasks teams with designing a rover to construct a berm from regolith in a 30-minute window. The team approaches the challenge by identifying requirements. The team generates and evaluates ideas to create a preliminary design. The rover is broken down into three primary mechanical systems for detailed design work. The mobility system consists of a four-wheel drive skid-steer drivetrain. The excavation system uses a bucket ladder to allow the rover to achieve a high rate of excavation while driving. The hopper and deposition system consists of two belts for storing and depositing regolith. After manufacturing, the team tests the rover in a lunar simulant in order to prepare for the competition in May.
Multiplanetary INnovation Enterprise has opportunities for students across multiple majors to learn practical skills through being involved in an engineering process. Within our 3 projects, members have opportunities to work on mechanical and electrical design, manufacturing, programming, testing, and much more. Our hands-on approach allows for each member to gain experience from the design phase to the completion of the project's goal. I would like to thank our members, our faculty advisor, Dr. Paul Van Susante, and our sponsors for all the work that was put into achieving our progress this past year. Additionally, on behalf of Multiplanetary INnovation Enterprise, thank you for listening.